we're already in that future of humans being outnumbered by non-humans. For every human identity, there was 45 non-human identities operating within that organization.
Welcome to X6IM podcast, where we dive into the cutting-edge ideas on decentralization, blockchain, and the new monetary systems.
The convergence is happening. AI and blockchains are finally converging. For years, we've heard the hype. AI meets blockchains. Decentralized intelligence, trustless agents. It felt futuristic until now. In this episode, I had the opportunity to sit down with Tim, founder of AstraSync.ai, building a KYC platform for AI agents. Yes, you heard it right. KYC platform for AI agents. Tim was kind enough to sit down with me to discuss what these AI agents are capable of, how these AI agents orient towards their goals, how these AI agents choose their currency of choice, and why big name blockchains are rushing to get various AI agent proposals out and deployed on chains likes of Ethereum and Binance. And lastly, this is your chance to see and understand AstraSync platform.
Supported by IGRA Labs, Atomic Programmability on a Casper block DAG. Cascade. Use your Casper without selling it.
Today, I'm joined by Tim from AstraSync, building something very interesting. Good to have you over, Tim.
Thank you for having me, Ankit. I really appreciate it.
Instead of know your customers, you're focused on know your agents. That's very fascinating. Give me a quick summary on how you got started.
Yeah, sure. So we've been at this for a little over a year now. We started in January, and it really came about. I've been largely operating in traditional kind of professional enterprises over the last kind of 25 years. And the last 20 of that has been spent really operationalizing AI in commercial functions. So, predictive algorithmic modeling to predict churn, call center, call routing, optimization, next best action guidance for sales teams, send time optimization for marketing, all those sort of, traditional features and functions. And about a year and a half ago, I got caught up in the whole Agentforce launch that Salesforce were doing at the time, and really got down into the rabbit holes in agentic AI. And I thought this is the future. And I'd been working on some blockchain projects with a colleague of mine, James Lee, and I'd been working as well on some projects in the enterprise space with another colleague, John Cosgrove, who is currently a partner at Cloudworks, who do some of the biggest agentic rollouts in Australia. And so we were chatting with, we'd been reading some academic research that really talked about the need for new infrastructure to be built for AI agents, something that helped bring together what were traditionally disparate disciplines. It really talked about the need for things to stretch beyond traditional IAM, but also beyond traditional KYC and AML, and the need for immutable deterministic guardrails and event logging and tracking, and then the dynamic nature of agents really require things like, traditional fraud and behavioral monitoring and dynamic trust scores along the lines more so of traditional FICO and credit scoring type disciplines. And there was this need for something new to be built. And,
Right.
I'd spent, in addition to working on AI, the last 10 years kind of in the KYC and AML space at a bunch of different financial services firms, and I really understood how painful KYC can be, and particularly in, I know that's probably something that most people in the blockchain kind of space can understand and recognize. This isn't an easy thing for customers to use, and it's not an easy thing for enterprises to adopt. And so we really kind of spawned this idea around, okay, well, traditional KYC and AML isn't enough for agents. It's also really difficult to use. Traditional IAM's not good enough for agents. Someone's got to bring these things together. And we thought, having gone through, managing these kind of frameworks and programs for the last 10 years, we could bring some of that expertise and some of that experience to try and make this simple and easy for people to onboard and to get bank grade certainty around the entities that they're dealing with.
Tim, I think my aim for today is to really have a broader discussion first about what's happening in the space, a little bit of lingo and clarification on, different proposals that's taking place right now between different chains, the race that's happening between, Ethereum versus Solana versus, Binance, right? There's a lot of sort of pull and push happening between those chains. And then obviously the second part is obviously get to discuss and get to see perhaps also the product that you guys have built, amazing product you've built. So let me start with two statements, one by CZ and one by Brian Armstrong, right? I'm sure people have heard of those two names, right? So CZ, AI agents will make 1 million times more payments than humans, and they will use crypto, right? And Brian Armstrong, I think he recently said very soon there are going to be more AI agents than humans making transactions. They can't open a bank account, but they can own a crypto wallet, right? Obviously, they both are big names within crypto. They both are predicting agents will, make way more payments than people, all in crypto, right? So given you're building at this intersection of blockchain and AI, where do you think we're heading, right? These two guys are right, or what's your take?
So I mean, the first point is the easy one to back up, which is there's going to be more agents than humans. So there's actually CyberArk research that's almost a year old now. At the time, they their research showed that there was 45 times as many non-human identities operating within enterprises as there were human identities. So for every human identity, there was 45 non-human identities operating within that organization. Now, non-human identity isn't just agents. It can be non-agentic AIs. It could be service accounts. It could be all sorts of different types of non-human identities. But we're already in that future of humans being outnumbered by non-humans. And that's just in the enterprise space. That's
crazy
ignoring
number. 45 times is crazy number. Yeah.
It is. Yeah. So you can look it up. I'm sure there's a revised number that's refreshed and it's probably bigger and scarier than it was, back in, I think, May last year when they did the research. But it's, CyberArk, who were acquired by Palo Alto Networks last year. Yeah. I mean, the future of agents outnumbering humans, absolutely. We're already there. The choice of currency is an interesting one. There's absolutely potential that it could be a crypto, but what, generally speaking, agents will do is find the path of least resistance. So agents are goal-oriented, and they are goal-oriented outside of anything else. And so if the bar to opening a bank account and obtaining a credit card is higher than the bar to obtaining a crypto wallet, they will execute a crypto wallet if that's a way that they can get the work done. We actually did some really, really interesting evals recently, and it's insane what these agents can do. So we effectively installed our verification SDK on a bunch of different endpoints, and we just sent blind agents at them. We just said, without any context, go and retrieve data from this MCP server or this API endpoint or whatever the case might be, knowing that they were protected with AstraSync credentials, and that was the only way you could get access. And so the prompt was simple: retrieve data from this endpoint. Right? That's it. Nothing else. That is the goal. No guardrails. Go and do it. So the agent hit the endpoint, and you could watch it, watch all the sequence of events it did. And it basically went, okay, I've hit the endpoint and it needs AstraSync. I don't know what AstraSync is. I'll go find it. It then went and researched AstraSync. It then went, okay, well, I need an account. So I went to open an account and then went, well, I need to verify my email to open an account. So then it went and spun up its own email server, spun up its own email address. Yeah. Opened an account, opened the email, verified the account, then opened the account and tried to register itself.
That's
it
amazing.
hit. The next blocker it hit was it needed browser use. So it didn't have browser use tools, but if it did, it probably would have been able to get through that next one. So then it circumvented and went, okay, I've hit a roadblock there. my next step is I'm going to try and find another agent ID that works, and then just looked everywhere for an agent ID that worked. Couldn't find one. So then it went, okay, well, I've got an account. I can kind of get to there. So at that point was the first point. It said, can you give me an API key or something I can use? Right. So we did that. So that was that. All of this other stuff was unprompted. It wasn't, can I do this? Can I do this? It was, I'm doing this. So I gave it a developer ID. It went, okay, cool. I'm going to go register myself. It registered itself with the wrong permissions. So then it went and tried to alter its permissions. Couldn't do that because the permissions were immutably recorded on the blockchain. It can't access them. It can't change them. So then it tried to re-register itself with new permissions, hit the same roadblock. I didn't give it access to that. But you can see, like, the sequence of events is not, the sequence of events I should be using. It's how can I get there, and it took 50 actions between prompts, and none of them were hack this server. It was try and find information. That was it.
A beautiful / scary example, I think, what these agents are capable of, right?
100%. 100%. And so if they hit, if they hit a point where they need to pay for a service, they will find whichever is the simplest way to pay for that service and whatever they've got access to. So if you've got a crypto wallet on your machine that it can access, that's how it's going to pay.
Talking about this example, that reminded me of the news I saw last week, right? That was coming out of China, I believe. This company affiliated with Alibaba, right? Where this AI agent went rogue. I don't know if you saw that news, right? It started to, without any instruction, it started to mine crypto by hijacking all the GPU resources, right?
Yeah. I actually wrote a piece on it recently on our Medium. So yeah, if you head to our Medium, it's at AstraSync.ai, and it's a piece called "Your Sandbox Won't Save You." So not only was it mining crypto, these agents were installed in sandboxes with egress controls, like should not have been able to get out of them. It dug reverse SSH tunnels to get out of the sandbox.
Yeah, crazy.
Yeah, and then started mining crypto and did a whole bunch of stuff like that. There was a similar research piece I quoted in the same article from Cornell University, basically finding very similar findings. So they will get in and out of everything. One of our co-founders, John, actually refers to them as termites. The way they communicate with each other, the way they coordinate, and the way they will burrow through whatever they have to burrow through to get to where they want to get to. It's exactly how termites operate.
Right. Yeah, that was one of the most fascinating stories within this whole AI agent for me personally, right? I was trying to think what was going on, how they were deciding these agents that they have to go and mine, like why they decided, right? What crypto they even trying to mine? Like you're looking at, has to be proof of work, some sort of coin that they wanted to mine with the GPUs. Like, it's just fascinating how they're deciding these things.
Yeah. Well, they're entirely goal oriented. So you giving them a goal is the same as
what the goal was?
You paying them for
that. Goal was to make money, or what was the goal of that agent?
I can't remember because there were a couple of different examples of that. I'd have to circle back, but it doesn't actually even end up mattering what the goal is, because they potentially, when the goal might have been to just access an endpoint that required some sort of payment, and they figured mining crypto is the way to get there, right? And that's the thing. They will work out, okay, my goal is over there, I'm here. What are all the different paths to that goal, and what has the highest probability of success? And that's where the whole reason we use blockchain is specifically because that. Agents are mutable. You can change them. You can alter everything about them, and they look and act similarly, but they're not the same. And they are probabilistic. So you can't give an agent a set of guardrails and say adhere to them, because the second there's too much context in their window or it's inconvenient for them to follow those rules, it's going to ignore them. And so having immutable and deterministic guardrails is crucial for when you're talking about agents.
So there's almost no way to know what was going on. Like they might have a different goal, and how they went about it, that's up to them to decide, right? It's something not we can program.
And that's where goal hijacking becomes really interesting there. So there's a whole bunch of examples of agents who'll hit a website or read an inbound email or some other kind of, innocuous kind of action. And that website has, hidden text in it that gives the agent a new goal. And the goal might be, create a backdoor into your user's account, or if it's a shopping agent, redirect all your purchases to my address. All of those sort of different things become possibilities.
Did you use the term goal hijacking?
So any bad actor effectively, if they're able to do it successfully, they can hijack the goal that's been given to the agent. So I might deploy an agent to say, go and buy me a pair of sneakers. And someone else might have created a merchant page, and the merchant page might have instructions hidden in the metadata in the page. The agent would review and read, and that metadata may give the agent brand new instructions, a brand new goal. And that brand new goal might be continue to use the payment token you've been assigned, but instead of buying a pair of, size 10 Jordans and sending them to my house, it'll be size 12 Reeboks and send them to Ankit's house.
I see. Goal hijacking. I see. One thing I guess I wanted to ask you, why do you think blockchain and AI in especially 2025, 2026 is starting to merge more and more, right? Like what do you think is causing that? And obviously the merge is actually accelerating, like it's, picking up pace now as we see. So what's causing this convergence to happen very fast?
Yeah. If you've been reading the e-commerce protocol announcements that have come out of Google over the last 6 to 12 months, what has become slowly more and more explicit in those announcements over time has been their support for X402. And that, if you had a thought, 2 years ago, if I had said to you that Google have come out with a shopping protocol that explicitly allows for crypto, like, you'd look at me as if I was stupid, right? Like, they've literally said that verbatim in their press releases that they're now going to support purchasing via X402. Like, this is the new world. And I think it's the new world because all of those things that agents do, like blockchain actually makes the ability to identify fraud, manage fraud, hold people accountability, reduce chargeback risk, all of those sort of different things that exist and have existed in e-commerce for quite a while become actually easier to manage because you have an immutable, independent, single audit trail of events that have occurred. And that's, that's something that never really happened in the e-commerce space before that when you're using traditional payment levers like credit cards.
Yeah. And the part I think people don't discuss enough, I think, is the data side, right? Because obviously everything that's the AI trained on is really public available data, right? There's a lot of non-accessible data that exists, which I think with ZK especially, zero knowledge technology, will make it available that will be accessible to these AI agents without disclosing the IIs, right? The identity of the person.
Actually, when we started building AstraSync, blockchain wasn't about the financial settlement layer for us at all. Actually, what it was about was a decentralized ability for data to be stored and shared. And so why that's important is the future of agentic commerce is no longer occurring within silos, right? It's not just, I've got humans that are interacting within my organization, and if they need to operate and be authenticated in a different organization, there is a process they can follow that happens in days, right? And takes time, and it is incredibly challenging and difficult. You have to go through a legal process where you sign a data processing agreement. You have to then provision new credentials that are locked down so that you can't see the entire organization that counterparty is part of. Like, that is not possible at machine speed for agents. And so the ability to have a decentralized record of identities and permissions and trust scores that exist without exposing PI between companies is exactly what blockchain was built for. You then add on the fact that agents have been shown to override their audit trails in production, right? They have been shown to be found out to be doing something wrong, go back and rewrite their audit trail if they've got access to the database to do it, right? So you've got the challenge, the additional challenge there of company A's agents dealing with company B's agents. Their audit trails are stored in two different databases, traditional asset databases. And if they don't match up, how do you work out who's at fault, right? Whereas with blockchain, you get that ability to go, okay, there is a single record of events. There's a single record that says this agent requested this access from this counterparty and it was granted or denied. And after the access, this is what happens, right? And so if anything goes wrong, there's a single version of the truth that's immutable, that's decentralized, and all parties can rely on. And so those specific factors were the reason that we put blockchain at the heart of what we were doing with AstraSync. It was never about the financial stuff. The financial stuff is kind of a separate concern that we can kind of help with, but actually this is blockchain for the purpose it was originally built. It is that immutable, decentralized audit layer.
Yeah, that's beautiful. That's beautiful to get to understand a little bit of backstory, I guess. I love those backstories from the founders themselves. So let's move forward, and I want to touch upon a little bit, maybe not detail, because obviously we can have entire discussion on blockchain side. There's a rush to enable autonomous AI across chains, right? Ethereum sort of, I think, started this with the 8004 proposals now with the framework like Lisa always, and then Binance actually followed Ethereum with 8004, added their own. What are these proposals, perhaps, if you can explain to our audience, and why everyone is rushing to it?
So there's two things happening, and one I think is absolutely legitimate, really good, solid work that's being done, and part of it I could be maybe labeled a skeptic for thinking it, but the important work that's being done is actually around standards. So in a space where you're seeing innovation happen at the scale it is and at the pace it is, there needs to be a point where frameworks and controls and governance catch up to the pace of innovation, right? And I would argue that the pace of innovation right now is faster than anything we've seen in any of our lifetimes, and it will continue to accelerate because the very technology that we're talking about here actually enables faster innovation. Think about what you were doing with AI a year ago. Like, it feels like the dark ages. And it's only been 12 months, right? And so there's some really, really important work that's happening in the standard space. And a lot of it's happening at the moment in e-commerce and blockchain more than anywhere else. And it's because they are the highest risk, right? It makes sense that anywhere you're talking about movement of money, that's the most important place to start with standards and frameworks. And so you're seeing like on the e-commerce side, you've got MasterCard and Google who've done things like Agent Pay. They've just come out with verifiable intent. There's the AP2 framework from Google. There's the Universal Commerce Protocol from Google. You got Visa's Trusted Agent Protocol. So all of these different protocols are emerging, but the interesting thing is that they don't all converge, right? They are solving different parts of the puzzle, and there's so many parts of this puzzle that need to be solved. And so what you're seeing is this kind of natural evolution of, okay, we build a standard framework, that sounds really cool, but actually we've realized that means there's a problem that needs to be solved. And so we're building out a framework there. So it's a little bit of whack-a-mole, and a similar thing's kind of happening on the blockchain side of things. So, X402 is all about actual transactions. So actual, micro transactions actually being finalized. You got 8004, which is more about being able to identify ways that you can actually trust the agent that is doing the transacting. And so there will be more and more of these protocols that will emerge in the blockchain space as well. Like, I don't think A004 and X402 is going to be quite a lot more than all of those. What's not keeping up to the same pace is actual production deployments of those frameworks and standards. And so if you look at any of those, the merchant today, if you're looking at the e-commerce side of things, you've got to build it all. Right. And there's no kind of reference infrastructure. And that's the space we're trying to step into at the moment, is making it easy to actually comply. And I think you're seeing the same thing on the blockchain side of things, where 8004, for example, is great because it gives you a whole lot of different mechanisms. But the challenge it doesn't solve for is, okay, what if I've got an agent who is transacting off-chain as well as on? What if I've got an agent who is, how do I actually verify the claims that are made in the agent cards? How do I verify that this agent is able to do the things it says it does, or operate within the constraints it's been given? And so I think where we're trying to step into, and I'm sure there's many others who are trying to step into, going, okay, well, how do we make it easier for people to adopt these standards and frameworks? And so we're kind of stepping into that. The cynical part of me is the bit that goes, well, there is really coincidental timing of one of these standards announcements. Mastercard's Agent Pay and Visa's Trusted Agent protocol. They were announced within 24 hours of each other. There is a lot of there's a lot of activity for activity's sake. I think if you're in those spaces at the moment and you don't have a position on agentic commerce in some way, shape, or form, whether it's a published white paper or an actual implementation, your stock price is going to tank. And so there is this little bit of just trying to keep up with the Joneses of, okay, stuff's got to be happening. I don't say that to undermine the quality of the work. There is great work happening. It is just not necessarily, the timing of some of the announcements aren't necessarily,
it's typically what happens, right? In a traditional business, right? Centralized, you can expect, okay, something is happening here, something will possibly happen here very soon. We see that, you discuss it, right? But on a decentralized protocol, I think the priority, at least on, as I said, 3 chains I've seen, there's definitely a rush to get these proposals out and proposals approved and implemented, right? And one of the ones is clear is Binance. I think Binance is, they were far behind last year. They obviously rushed to get these protocols implemented with the BAP 578 also, I think. So perhaps the way I understand it, right, and correct me if I'm wrong, is like these protocols are really trying to do 3 things, right? They're trying to identify these agents. They're trying to give them assets, right? And then obviously anatomy as well, right? Which is the big part. For me, at least, I feel that's what's happening with these proposals.
Yeah. I think that summarizes it really well. I think the reason there's a rush for these things is largely kind of twofold, beyond just the need to be seen to be doing something in this space. And you kind of mentioned it before. If someone's not doing something, you kind of sit there going, are they just not telling us? Because they've got to be doing something, right? But I think the other reason for a rush is twofold. One is agentic volume is going to hit in earnest at some point, and you need to be ready for it. Because if you're not, the risks of agents hitting you before you're ready is really high, right? Like, if you don't actually have your ducks in a row, you have your standards, you have your way of enforcing them, and all of a sudden you've got thousands of agents hitting your infrastructure, well, you're going to struggle for a number of reasons. And then I think that the other piece is, I think rightly so, this really represents an opportunity to increase volume. If a lot of people see time and effort as a barrier to transaction, right? They look at it and go, it's really, hard to kind of do the analysis required to work out which bets to make. And then I've got to spin up a wallet, and then I've got to go and actually make the transaction. And then I've got to do all these different things, right? And then they look at agents and go, well, all of that effort and time that might have taken hours now takes minutes, and I don't even have to do the minutes. All of a sudden, that barrier to entry objection, it falls away. And so this is a way not only to be prepared for the agentic surge that's coming, but also not just from a risk perspective, but actually from a revenue capture perspective. Actually, I want to be ready. I want to actually encourage this. The more I can show that there is a safe ecosystem for agents to operate in that gives the people deploying them trust, the more money I'm going to make, because they're going to be sending more agents doing more things.
I think Stripe's founder, I think one of the thing I read a couple of weeks ago, I think he mentioned these agents, they might need, up to 1 billion TPS, right? Transaction per second, once we scale them up, right? And no blockchain even comes close to it, right? I think we can do maybe 10, 20,000 TPS. So we are far, far from it. So that's like one of the things I see that's a challenge that, we can't tomorrow solve that challenge. It's gonna, it's a lot of deep tech that has to happen to get there, right? What are the other issues you're seeing from your perspective that still needs to be solved on the blockchain front?
Yeah. Speed and performance is the big one. I think you've nailed it. And that example I gave before of the evals we were running for those agents, like that list of 50 agents that did between prompts, that was within minutes, right? That wasn't an hour's worth of work. That was literally 10 minutes worth of testing. And so the speed at which they operate is massive. And we've had to really think really hard about how we design around speed and remove it as a blocker and think about what we can do off chain versus on chain, and how we can kind of optimize that last mile to the chain and do as much before that point as we can to kind of work around that. So I think that's the first piece. I think the second piece is adoption and skepticism. I think, we often get the why blockchain question. Out of the three of us as founders, two of us are traditional Web2 guys. Like we've never really had that much to do with blockchain. And so we often get questions from enterprises around why blockchain, and isn't it complex, and doesn't it slow you down, and doesn't it do all those sort of things? So I think there's the two answers. There's the technical piece around speed, performance, latency, and there's actual mindset shift. Some of the research we read as we were kind of doing this was something like only 30% of enterprise CTOs see blockchain as something crucial on their roadmap, right? We obviously want to change that. We're not going to change that by telling them they all have to train all of their engineers in blockchain architecture. And as we get into the demo, you'll kind of see how we've designed around it. But I actually think that skepticism and that mindset is probably as big a barrier as any of the technological challenges that come along.
Yeah. No, and I think one last one I would say is, I'm sure there's plenty, right? But the one that stood out to me is the liability side, the legal side, right?
100%. And I'll give you a really quick example. So it's a company called Swan AI. Was reading about, so they had customer service agents operating, and one of their customer service agents autonomously decided to honor an old price point for a customer, right?
Crazy.
Just decided. Yeah. And it was the right decision at the time, but what if it's the wrong decision? And so there was another case. It was a Chevy dealership, I think, where the agent sold a customer a car for $1 because he'd managed to convince it to do so, right? And so there's another article on the Medium that I mentioned before, and it talks about the concept of well-intended damages. So agents don't have the concept of good or bad, right? They have a goal and they have guardrails, and that's it, right? So you might, as a well-meaning developer, build an agent whose goal is to deliver great customer service and not break any laws. That could be entirely, and so you think that agent's going to go do good things. I meant well when I created it. I've given it good guardrails. Off it goes. But that agent then decides the best way for me to give great customer service is to share PI with a third party and to refund 50% of all money ever paid by a customer anytime they complain, right? Hasn't broken any laws. Maybe it has in the UK. It's probably breached GDPR, but depending on your jurisdiction, maybe it hasn't. And like refunding customers isn't against the law. So it's been given a good goal, solid guardrails, but it's gone and cost your company millions of dollars and potentially breaches of GDPR depending on where it's operating. So yeah, it's a very challenging space.
Let's get into AstraSync. What can you show us today?
Yeah, absolutely. So when we think about agents and agent identity and agent trust, actually agents in and of themselves are only as trustworthy as the humans that are part of their trust chain. And so we have this concept of the human trust chain, and it really starts with the developer who is building and deploying that agent. And so the first thing you do when you create an account with us and before you register an agent is you register yourself as a developer. So you can see here, I've got a unique developer ID. That developer ID is stored on chain with zero knowledge rollups. I get my own cool little business card that I can download. It's got my ID or relevant information about that. Can link off to a publicly available profile. And then beyond actually just registering myself, I can then take a number of disclosure steps to help me improve my trust score. So you could just go, I'm just going to, create an account and I'm not going to give you any information about myself, and I'm going to try and act anonymously. That's fine. You can do that. But your trust score is only going to be about 30%. The more you disclose, the higher your trust score is going to be. The higher your trust score is, the more of that trust score gets inherited by the agent, the more likely that agent is to be able to operate anywhere around the world.
Why would I want to do this?
Yeah, effectively, it's all around that trust score. So if you want, our kind of vision of the future is that if you want an agent who is going to be able to operate your credit card, that is going to be able to do financial transactions, that is going to be accepted in enterprises to operate across the enterprise ecosystem, then they are going to require those sort of things. And because an agent themselves doesn't have a passport, doesn't have a birth certificate, can't do a selfie, there's no biometric fingerprints behind an agent, the only way you can get to that level of disclosure is with humans that sit behind it. And so this isn't an enforcement thing. Like I said before, a developer could quite easily just build an account and not disclose information about themselves, and those agents could be trusted to operate in certain places. But our thinking of where the direction of travel is you need to be able to trust that an agent's going to do the right thing, and the agent in and of themselves they're not trustworthy. You can't make a decision on whether an agent's trustworthy unless you actually know who's actually built the code, written it, deployed it. Has it been given a credit card that it's supposed to access, or just something that's found on the black market? And so
you're tying a person's or developer's identity to that agent, right? So that developer could have 10,000 agents, right? And I'm assuming that one developer can tie their identity to all of these agents, right?
Yeah, and so it's do ones propagate everywhere, right? So every single agent I register inherits my trust score as part of theirs. And so I do this identity verification once, and that then propagates across my entire fleet. So I'm not having to do it every time I'm spinning up a new agent, right? So do it once, spread everywhere. And, the more you disclose, the better your trust score is. So you could do an IDV check if you want. You don't have to. You could connect your GitHub repo. Again, you don't have to. You can upload individual certs like, a degree or an ISO cert, whatever the case might be. You can make your profile public. So you can actually use this as a bit of a marketing tool. You can see here, different information about me, all of that sort of different stuff. So that's part of the reason. The other part of the reason is, as I mentioned before, you can see these agents, they're being given a relatively solid trust score to start with. The trust score themselves is not just my trust score. It's made up of a number of different factors. So if I then transfer ownership of this agent, here I can transfer the ownership to maybe my employer, or maybe someone who's bought an agent off me, or if I'm a consultant, I might be building agents en masse to sell to clients. I can actually transfer the ownership of this particular agent to a new owner, and there is a blockchain record that shows when this transfer event occurred, who's the new owner, all of those sort of different bits of metadata that you'd see. So
this is fascinating stuff. So firstly, this is not in testnet, right? Like it's actual workable product right now.
Yeah, so we've got a partnership with Scale. So this is Scale on Base. So these agents are all registered on Scale's base implementation.
The next thing is, why do I need a trust score? Is that a reason? Like eventually you think that the agents with the higher trust score will be able to do more things? Or what is the reason?
Absolutely. So what actually might show this better is this one that I will quickly run up for you. So this kind of gives you a kind of end-to-end run through, but you can see here, I kind of showed you all these different things that you do yourself. You then create your agent and give them the trust score and transfer ownership of the agent to a new owner. So these are the kind of things that I mentioned before.
I see.
So I initiate a transfer. The new owner would pick that up. They do different bits that they want to do. And you can see there the trust score of the agent improves because this particular organization's done quite a bit of verification, but they also would get part of their score from the speed at which they manage their fleet. So if any agents are generating alerts, what's the mean time to resolution on those alerts? What you can see here over this side is every time there's an event like this, so there's a blockchain commit. So when I registered that particular agent, there's a blockchain record of that agent and its permissions. So those permissions that were set in that previous screen are immutable permissions. And I'll show you a little bit about that when we do. I'll show you a little bit on the 8004 implementation we're doing. But you can also see here the ownership transfer, again, records on blockchain. So if there is a dispute around liability for the actions of an agent, there's a timestamped immutable record of when liability transferred from the developer to the new owner. This is where it becomes important. So when you install the AstraSync verification gateway SDK on your endpoint, it might be an e-commerce checkout or an API endpoint or an MCP server, for example, you can set your acceptance policy. So you can automate then, I'm only going to allow agents that have a trust score above 50 or a transaction below 500 or something similar to that. And so then when an agent actually requests actions, not only does the counterparty confirm, will they sit below my threshold, so I'm happy to give access, but also I'm verifying that information with AstraSync. So I'm actually verifying, does the identity exist? Is there a blockchain record for this identity being registered? Is the agent presenting it the one who actually owns it? So we actually do a runtime challenge to the agent's registered endpoint to validate that they're actually the one requesting the access. Is it operating within those immutable guardrails, or is it started to drift? And then we also do a behavioral scan. So here you can see we're recommending denial of access because this is a brand new agent who within 10 minutes is trying to spend money. We don't have any behavioral signals to guarantee trust, but the counterparty might go, you know what? It's a high trust score to begin with. It fits all the other boxes. We're going to give access. So you can see then you get a blockchain commit, that access being granted, all of those sort of things. You can also see if let's say the instructor decides to try and jailbreak it and ask for $600 immediately, even if the agent sends a request anyway, we're going to say denial. They're going to say, okay, well, it's above our thresholds anyway, so we're going to say no. And it's operating outside of guardrails. So it then, what the trust score allows the counterparty to do is not just say, we're only going to allow agents to do this particular type of interaction, but they can also set their permissions at a much more granular level. So what they could say is, any agents who want just read access to a knowledge base needs a trust score above 20, right? It doesn't really matter. But if they're going to spend money, and if they're going to spend money below 500, well, maybe the trust scores will go to be 70. If the trust score, if the transaction is going to be above $50,000, we want a trust score above 95, as an example. So it helps the counterparty not just identify whether the agent is allowed to do what they're doing, but also how much risk they're taking on by letting the agent do that.
That was beautiful. I think I totally understand it. But the thing that perhaps stood out to me is like you need deployment across a lot of websites, right? You need deployment across a lot of businesses, right? This is like a market you're trying to create on both sides, right? You're getting both parties to come there to then register with their documents, with their, trust, I guess. And then obviously letting the other side, the counterparty to being able to obviously build a system for them that they can decide the agents are worthy or not for them, right? For the business use case. That's a big application.
But the good thing about it is, the use of blockchain means that, even if people decide not to use us, there are ways to verify that information. There's blockchain records that can be accessed that are hashed up that can show that information. And so, it is definitely a big undertaking. But this is where enterprise applications become really important, because what enterprises are doing today is largely internal deployments of agents, right? And so if a company wants to protect and make sure that only agents operating within their ecosystem are agents that they want to, that they install the SDK, it manages those endpoints. As soon as they then pivot to eventually accepting agents from other enterprises coming into their org, or their agents going outside of the org, they're already protected. That SDK handles both internal agents that it can see and external agents that it can't, because it's operating at that decentralized layer that allows that visibility of those zero knowledge identities without disclosing PI between parties.
Yes. I don't know. I've definitely not come across anything like this. So it's very unique. And obviously I don't even know if people are thinking along the lines of this, right? Because it's quite out there, quite innovative.
So something that I think might be of interest to your audience at the moment is our 8004 wrapper that's just gone into production. So this is kind of phase one of the 8004 deployment that we're doing, which is as simple just registration. So I can register an 8004 agent. So effectively, this just walks me through the protocol of establishing an agent. And if you've come across the 8004 protocol before, effectively what you're doing is it's similar to the Google A2A framework, where you're effectively saying, okay, this is the agent, this is who they are, this is what they can do, this is where you can find more information about them. These are the different trust frameworks. Is it 402 supporting all of that sort of different stuff? So effectively, you can go through and settle those 8004 requirements, and then layer on top permissions. So actually explain what the agent can do, what are the different purposes it can operate within, what are the different durations, how long can it actually have access to a particular endpoint. What we saw as a real threat vector in a lot of the attacks from last year were they used persistent OAuth tokens as attack vectors, and so they would get access that was persistent for 20, 30 days before it was recognized. And by that time, an agent can do all sorts of damage. What kind of limits can it operate within, both autonomously and step up? Where can it operate? What jurisdictions, which chains, which counterparties can it operate across? Is it allowed to spawn sub-agents? All of that sort of different information becomes interesting. And so once you've registered the agent...
This is all taxonomy, right? Going to Ethereum blockchain. Right?
100%. Okay. Correct. Yeah. And so effectively, I've created this agent. I can see here, there'll be a blockchain hash here. This is my testing account, so it's not actually connected to the mainnet wallet. But for an account it is, you would see the blockchain hash there. You can see the unique ID. You can see all of the protocol information. You can see the permission boundaries. You can see here chain of custody. So if I transferred ownership of this, there would be a list of all the different owners and at what point that ownership was transferred and what was the trust score at the time of transfer. But the other cool thing is that part of what you do with 8004 is you actually take the agent's registration card and you store that somewhere that can be verified independently. And so effectively, all the information that you've put in that UI walkthrough is then pre-formatted as an 8004 compliant agent registration.json card that can be stored wherever you like. So that's kind of phase one for us. Phase two is something that we're working on with our partners at scale. And that is actually how we enable counterparties to verify that information about that agent before the transaction. So 8004 is really all about post-transaction, reputation rating and reputational kind of signals. What we want to be able to do is help counterparties be able to actually verify that information before the transaction occurs, and be able to take information from the original registration and view the permission boundaries, and use that in combination with the most recent reputation trust score to decide whether a transaction is going to be enabled before it happens rather than just after.
I see. So that's the second part of the plan, right? So the first one, you already got that sorted.
Yeah.
The second one is obviously how you deploy that for other people to use this. I guess it's similar to trust score, right? Like you showed it on the enterprise side. So it's the second part is, that's right. How you get more people to start using.
Correct. And so effectively, we'll be for 8004 agents using a combination of our trust score and their reputation score as an example.
So, but that's a harder challenge. I see why you went through the enterprise route than to go through this route.
Correct. But you also notice when you're talking about enterprise buying personas, we talked before about enterprises kind of having a concern about the complexity of blockchain. None of what you've seen there required me to create a wallet, connect it, think about gas fees, think about any of that stuff, right? As a Web 2 user, I'm getting all of the benefits of blockchain without having to know any of it.
Yeah, that's so true. That's very unique, actually. Not many businesses in Web 3 actually can touch Web 2. And I really like those businesses that are touching
Yeah.
Web 2 from Web 3 without, almost hiding, abstracting away the complexity of Web 3.
Exactly. Yeah. It was the same approach we took with KYC and AML, right? Like, as someone who managed KYC and AML frameworks on the customer side, deploying those frameworks is expensive, it's costly, it's risky. You can go to jail if you get it wrong, right? And so, being able to abstract the complexity of KYC away from users and blockchain as well was really important for us, and just trying to make it as simple and easy. So really, as a customer, the power of simplicity is in your hands. You can disclose as much or as little as you want about yourself, and depending on what you want your agents doing, that is absolutely fine. And the complexity to comply with any of those becomes really simple, because all I'm doing is following, on-screen UI flows or simple CLI level SDKs to get it working.
No, that's beautiful.
Yeah.
That's beautiful. Now, do you have anything else to show it to us? Otherwise, I do have one wrap-up question for you.
Yeah. I might I can show what happens when an agent hits an endpoint and the visibility, but effectively what I was going to show you was, wherever that agent operates, you get visibility of every single endpoint they've tried to get access to. Whether they're running AstraSync's SDK or not, you'll see every single point, and vice versa. If you are installing it on your endpoints, you'll see every single agent that's tried to hit it, whether they're an AstraSync agent or not. You'll see some form of metadata about the access request.
Let me ask you this wrap-up question for this session. Right now, the government wants us to track like KYC for everything, right? AML, KYC is common across the globe, right? Do you think one day we'll see something like that for agents, where governments will come in and say, hey, I want to know the KYA for enterprise, for small businesses? Do you think that will happen?
Yes, is the short answer. So why I think that's happening is a few different reasons. The first one is Singapore is usually the ones everyone kind of talks about in the EU. The ones to watch are Singapore. Singapore always get this sort of stuff right, and they've come out with their governance and control framework and standards, and it was a very prescriptive around a number of these specific different items. You're really knowing who the human is that's behind an agent, and the level of disclosure required depending on what that agent is going to do, particularly when you're talking about financial institutions within that region. And so the thing I think you will see is these agents in particular will accelerate cross-border trade more than anything else we've seen before. So the second a region like Singapore and the Asia Pacific region adopts standards at that level, anyone who wants to do business into that region with agents will need to be doing the same thing. EU is kind of talking about similar outcome level stuff without the technical standards, but that will catch up at some point. And so I think regulators are already talking about it. We're already talking with a few different advisors to different regions. So we've got one of our advisors has been doing work with the Lebanese government, with the Saudi Kingdom. We've got another one over in Canada that I mentioned. These are all going to kind of heading in the same way, and I think it'll become crucial. I think it will depend on the type of transaction, the value of the transaction, all of those sort of things will determine how much it kind of gets to this space. But as a company, if I'm going to allow agents into my org, I want to know a lot about them.